What's up, guys? What's up, guys? Okay, so in this video, welcome to my analytic number theory video. So in this video, that I'm gonna to talking about the prime number theorem. Okay, or basically the prime distribution. And I plan to spend actually 3 videos to talk about this prime number theorem. So the first video is this one, that this is some elementary. And so elementary means that I will not use the derivative series without complex analysis. So if you want to look the derivation of the prime number theorem using a complex analysis, then you can go to the second video. Okay, the second video is standard prime number theorem that using a complex analysis. So basically using the derivative series, main transformation, Perennial's formula that you might need some basic knowledge that you can go to check my analytic numbers theory video list. Okay, and the third one, which is more advanced, is the prime number theorem with arrow term. Okay, and for this one, I may use additional videos. Okay, because this is not very difficult. Yeah. Okay. Okay, so today let's talk about some elementary results. Okay, so elementary prime distribution. Okay. Okay. So the idea is so what is the main question? The number theory. The number theory main question is that people define this pi of x, which is 1 divided by which is p less or equal to x. So this is the number of primes. Number of prime numbers less or equal to x. For example, pi of 10. Pi of 10 will be a number of the prime, which is 2, 3, 5, 7. So it will be 4. Okay. So our goal is to find asymptotics. So asymptotics of this pi of x. Okay, so the standard prime number theorem tell you that the p of x is approximate x divided by log x, 1 plus a small of 1. Okay, so this is proved by Gauss. And the least error term is very difficult, connected to the famous Riemann hypothesis. This is I will talk in the future more advanced videos. Okay. Okay, and but for people that if you this pi of x is very hard to attack itself. So people define another 2 function. One is theta x, which is count prime, but with the fact log p. And another is this von Mogel function, which is the psi of x. This okay, so I should say Vogel. I don't know how to pronounce this. Sorry, I just forget. Okay, so then some function. Yeah, so n less or equal to x, and then this Van Mogel function defined to be let's say if n is a prime power, you define log p, otherwise 0. Okay, so the idea is that people so zeta function is intermediate related to this psi of x. So you can, so in this video, basically I want to, so our goal in this video is that we want to find a relation between zeta x, psi of x, and the pi of x. So I want to say that if I know the distribution of psi of x, then I know the distribution of pi of x. So they are interrelated. Okay. Okay. So this is our theorem, which is a little bit difficult. Partly difficult because we don't use the complex analysis. Okay, so first one is that I want to prove that this psi of x is this is also the Vinogradov notation. Psi of x is approximate x, so which means that there is C1 and C2. such that the C1x less or equal to psi of x less or equal to C2x. Okay, for large enough x. Okay, and also second is that theta x is also the same thing x, and third one is that our pi of x is basically x log x. Okay, so this third one just tell you that we are not proving the prime number theorem itself, but we prove that there exists two natural constants which you sandwich is. Okay, so this is like the weak version of the prime number theorem. It's amazing that you can prove this, even though you can prove this weak version of prime number theorem that actually you don't need a complex analysis. Okay, okay, so maybe we'll prove these three, and this is maybe enough for this video. Okay. Oh, sorry about this. Okay. Let me just see whether. Oh, no. There is something that I talking about previously. So the page is a little bit. The page is a change a lot. Okay, sorry about this. Let me just reopen some pages. Whew. Sorry about this. Is it true? Is it true that it's blank? Okay, nice. Sorry about this. Okay, so let's prove the first one. What our goal is to prove this. How should I prove this? Okay, yeah. So this one is the most difficult one. Okay. So before okay, so how about let's do this. So let's suppose this one is true and let's prove the second. Okay, so my approach is that let's say theta x is this. Okay, so I first prove this is true, and I first assume that this is true and prove the second, and then we prove third. Let's say pi of x is this x log x, and then finally we go back to prove the first one. Okay, so basically probably this is okay. So let's prove this part. So let's write psi of x divided by theta of x will be, let's say, prime. So this is prime to x, right? Because each prime number will corresponding to this Mogul function. So log p minus p less or equal to x log p. Okay, so the standard approach is that I separate x into square root of x. So I can count this is p square root of x log p. This one is p equal to n log x divided by log p 1. Okay, this is just right. So if let's say if p squared is greater if p squared is greater than x, then the two terms will be the same. Sorry, so I only need to count all the prime number less or equal to square root of x. Okay, and then once I did this, then it will be something look like this, right? Because I need to count how many prime number m, how many prime power m that I can. So I take m times log p that's equal to log x, so I get this one. And since I already minus 1, so m count from 2. Okay, so simple rule, right? So p less or equal to square root of x and the log p. So I can easily bound this by just take the. Oh, by the way, so I use this to be a floor function. So log x divided by log p. This is a floor function. Okay. Okay, so easy to see that right. This is log x divided by log p because I eliminate 1. So now I can write this as I can use right. So log t will less or equal to t. So this is I can write as a square root of x log x. Okay. Okay, so which just tell me that psi of x minus theta of x is basically less or equal to square root of x log x. Okay, And obviously that okay, so we get some conclusion that our theta s is first less than equal to psi of x. Or this is trivial, right? But the psi of x, but theta of x also greater or equal to psi of x minus square root of x log x. Okay. Okay, so now it's proof, right? Because that this psi of x is when x grows very large, it's basically the, if you use the computer science, should be omega x, right? But the square root of x log x is less or equal to less omega x. Oh, right, because I mean square root of x log x less than x, right? Because square root of x is always greater than log x when x grow large. So once I prove this, and I know psi of x is omega of x, basically some multiple of x, then their difference is at most square root of x log x. So which prove the second, which prove this one. Okay, so this one will imply this one. Okay, so now we prove the third one. Okay, so third one is also I guess very simple, right? So first, pi of x is a summation of prime p, right? P that's equal to x. So let's do the lower bound, right? So this is greater than equal to 1 over log x, right? Because I divide by log x, and for p, that's equal to x log p. Okay. So this is just theta x divided by log x. Okay, so now if theta is x, right? So this pi of x is greater or equal to x divided by log x. Okay, so we get a lower bound. Let's do the upper bound. So this is a lower bound. Okay, so upper bound is that let's consider do the standard technique, right? X, and I use a square root of x. So pi of x is less or equal to pi of a square root of x. But these are all the prime here, and I want to count how many prime here. Plus, right? I want to count, so I should use 1, right? Square root of x greater than x. Okay. Okay, 1. Sorry, this is equation. This is equal, but less or equal to pi square root of x plus this 1. I replace this 1 to be log p. Okay, so I could just 1 over log x. I should take the square root of x, and, right? Because now I take this and divide and choose log p. Okay. Yeah. So this is p greater than the square root of x. So this is log p, right? But the smallest one should be log x square root of log x. Okay, so basically let me just write down. So I get pi of x, that's equal to pi square root of x. It's 1 over log x square roots, summation p less than x, square root of x, p. So this is a pi of square root of x plus 2 divided by log x, right? So you're just using the log property, and then this one is theta x, right? Because theta x come from log p from up to x. Okay. Okay. So who should prove that pi of x is bounded? Is this? Okay. And then I guess finally, sorry, and this is square root of x, right? So let's equal square root of x plus 2 divided by log x theta x. Okay, so who should I prove that pi of x that's equal to square root of x plus log 2 log x theta x? But let's greater or equal to theta x log x. Okay, and I know that theta x is omega of x, right? So this is x log x, and x log x greater than square root of x. So we prove our results. Very difficult. Okay, so this is true. So let's prove the first one. Okay, so first one is the most difficult one. Spend a lot of time. Let's try to do this. Okay, so idea is that let me just define this s of x to be the log n, less or equal to x. and I've defined d of x to be x minus x sx divided by 2. Okay, so we want to it's not immediately see that why this is corresponding to this psi of x. So remember that psi of x is the p to the n less or equal to x and the log p. So okay, so but s of x is easy to x of x is easy to approach. So remember that previously that this s of x, right, log n less or equal to x can be approximated by log x and dx from 1 to n. Okay, so s of x is basically let's say a log n, right, minus n plus the error term. So error term will be log x. Sorry, I made a stupid mistake because this is x. Okay, so this is a simple proof that I think you can go to my previous video or basically check out my list. Okay, so now we have this, right? So we can do the simple calculation for this d of x. Okay, and you can check by yourself that the d of x is basically O log of x, 2 times log 2 times x plus big O of log x. Okay, so this means that, okay, so you know that log 2, right? So log 2 is basically less than 1, right? Greater or equal to half. So remember that this is the natural log. Okay. So which tell you that the d of x, when x sufficient large, is bounded by x, right? And the less than x divided by 2. Okay. For some, let's say for some x greater than x0. Okay. So now we already make some progress, and finally we need to use the results that I previously proved. Basically, standard Van Mogel function with the derivative product will be log n. So this guy will be d divides n, which you can see that s of x can be written as this. Unless or equal to x, d divides n. Okay, so you can easily prove this. Okay, so just summation of n from right n less or equal to x. So you get s of x and you get this, but d less or equal to x and x divided by d. Okay. And then now our d of x will be x divided by 2, which you can just do some calculation. And you get, let's say this is f of x divided by d. Okay, where f is defined to be t equals to t minus the floor t. Okay, and okay, and there is a simple calculation. Sorry, 2 divided by t. Okay, 2. Okay, sorry, it's t minus 2 times t divided by 2. Okay. So this is a floor function. Okay, so just plug in everything you get. This is not difficult. Okay, and then your simple calculation that very trivial that you can show that this f of t, right? You can prove, right? If you can prove that if t greater than right? I mean, you can try to prove. Okay, so let's write this. Very simple calculation. Let's say 2t is 2k plus epsilon. Okay, and your f of t will be 2k plus epsilon minus 2 divided by k plus epsilon divided by 2. Okay, so you can easily show that this f of t is if epsilon divided by 2 is let's say negative a little bit, then you get the f of t is 2, right? If you get it's a little bit negative, then this guy will be k minus 1. Okay, otherwise okay, so this is the first case. Okay, but there may be a case that this t divide right, this is for if this epsilon is somehow larger, then somehow maybe let's see. So t equals to, okay, so that's, yeah, okay. So now I find f of t is max is 2, right? Because if epsilon is a negative a little bit, then you get this one. Otherwise, that there is a chance that f of t, I think you can try to prove this. Something like, yeah, you can try to show this, show that f of t is, let's say, you can also show, let's try to find the minimum of this f of t. What is the possible f of t it can be? Right, because this is a floor function, right? So somehow like yeah, okay. Yeah, so f of t can be 2, right? Or f of t maybe 0 or 1. I think you can try to prove this. F of t may be 0 or 1. Okay. So I mean, in any case, this f of t probably is at most 0, 1, or 2. Okay, basically, or f of t. Maybe let's forget about this. F of t is less or equal to 2 or greater or equal to 0. So I just want to say that f of t is bounded. Okay, so whatever it is, it's bounded. You can check by yourself. Okay. Okay, so this means what? This means that let's consider this d of x. Okay, bad idea. Very bad idea. This is sorry, bad idea. So f of t, actually f of t cannot be 2. F of t can only be 0 or 1. Okay, so let's put this. Oh, sorry about this. I'm stupid. Let me just see whether this is true. Okay. So first I know that this t is less or equal to t, and then this t is also greater than t minus 1, which tell me that the f of t is the largest one value possible is 2 and then minus 1, and the f of t is let's say t is an integer, right? So f of t now be the integer. So results will be f of t will be 1 if let's say t greater equal to 1 and less than 2, or t less greater equal to 2, then maybe a different like 0, 1. So you can check it. I think one can check this by yourself. You can consider t is 1 that you get 0. Sorry, t is 1 you get 1, and if t is 2 then you get 0. So f of t is actually at most 1. Okay. So which tell you that this d of x, if you replace this by 1, right, then d of x is less than this than psi of x. Okay, so your result is that d of x is let's say less or equal to psi of x, and greater or equal to psi of x minus psi of x divided by 2. Okay, the reason is that this guy, right, this guy can be, you can just, okay, so let me just write this. So this is trivial, right? But one can write d of x is greater or equal to, let's say, d less or equal to x divided by 2, psi of x minus psi of x divided by 2. Okay, we can try to prove this, right? Okay, so which means that okay, so now we got something. Okay, so now what we got is this. Let me just write down. So d of x is less or equal to psi of x greater or equal to psi of x minus psi of x divided by 2. And remember that we just proved that d of x is less or equal to x, that d greater or equal to x divided by 2. Okay, using our previous results. So these tell you that psi of x is greater or equal to x from these directions. And right, because sorry, but these tell you that this is stupid. But these tell you that right, you start from this. So let's combine these, and the d of x is less or equal to d of x equals to psi of x, and the greater or equal to x divided by 2, and the d of x plus psi of x divided by 2, that greater or equal to psi of x, so equal to x plus psi x divided by 2. Okay, this one is simple. You just connected this and this. And for this one, that let's say, so psi of x is right, this, and the d of x is a, right? Okay, so we get these two. Okay. Okay, so now okay, so now we are very close. We're very close to the answer. Okay. Because this now d of x is like linear growth, so psi of x is lower bound is linear growth. Okay, so it seems so. Finally, it seems so. Psi of x is already got a lower bound, like the linear growth. So now the final result is that we want to prove that psi of x has the upper bound of the linear growth. So this is the lower bound. Okay, and now we need to find upper bound. So basically, we want to show that if psi of x is equal to x plus psi of x divided by 2, then the psi should be linear growth. Plus our sum results. Okay, so yeah, psi of x should be linear growth. Okay, so that means psi of x cannot grow too much, right? For example, if psi of x is a quadratic, then this equation will not hold, right? Because this is x squared, right? X squared cannot be less or equal to x. Okay. Okay, so let's just try to prove it. So you can write psi of x less or equal to, you just keep using this equation for multiple times. Then you can get this. Say x divided by 2 to the k. Okay. Okay, so let's choose I choose some x zeros such that x divided by 2 to the 1 minus k greater or equal to x 0. And I choose x to be such, let's say this x 0 is fixed. Okay, and I choose k to be the maximum number such that when I divide by another x, then it blows up, then it becomes smaller, right? So that's really stupid. This is k minus 1. So I choose a maximum number such that x divided by 2 to the k minus x 0, and then this is 2 to k. Okay. Then okay, so that makes psi of x, right, is definitely less than psi of x 0. Sorry, psi of x divided by 2k, 2 to the k, is less or equal to psi of x 0 because these two relation, which give you psi of x is less or equal to I from 0, k minus 1, x divided by 2 to I plus x 0. Okay, so this looks stupid that I just plug something into x 0. But this tell you that this is 2x plus psi of x 0 for some fixed psi of x 0. So you prove that psi of x is linear growth. Okay. Well, this proof technique is very amazing, right? It's very amazing that, yeah, intuitively, if you plug less x divided, if you plug less psi of x, right, to be x to the alpha, then this equation will not hold. Okay, but the proof is very beautiful that it fix some x zeros and try to do this. Okay, then you prove that psi of x is linear growth. Okay, once you prove psi of x is linear growth, then theta of x is linear growth, then pi of x is x divided by log x. Okay, so this is our first approach, and the next approach that I will talk about the complex analysis approach of the prime number theorem. See you guys next videos.